Imagine this. Okay, you can create a high-quality 3D model,
Yeah.
and it only takes like half a second
Wow.
from just one image.
Yeah.
And it uses this new method, SF3D, developed by Stability AI.
Oh, very cool.
And I know you love machine learning,
Yeah,
so I
absolutely.
think this is going to be super interesting for you.
I'm excited.
Yeah. So this deep dive is going to be all about SF3D.
Okay.
We're going to unpack this research paper that describes it.
Sounds good.
And I think one of the most amazing things about SF3D is that it's tackling this
Fundamental.
this fundamental challenge in computer vision.
Yeah.
Which is like getting depth information
Right.
from a single 2D image.
Exactly. And, the paper highlights how other methods out there, they're either super slow or they need multiple pictures or the models just aren't that good.
Yeah, they end up with like low quality models.
Exactly. And that, that limits what you can do with it in the real world.
For sure.
Like, imagine you're trying to make a 3D model of something to sell online. If you had to use those old methods, it would take forever.
Yeah.
It would cost a ton of money.
Totally. So SF3D is looking to be faster and better.
Yeah.
But how does it actually work? Like, what are the big innovations that make this possible?
So one of the coolest things is they use this enhanced transformer network to analyze the input image.
Right.
And this network creates this high-resolution 3D representation called a triplane.
Triplane.
Yeah, you can think of it like a blueprint for the 3D model.
Okay.
And
great.
get this, SF3D increases the resolution of this triplane a lot.
Right. To what?
From 64 by 64
Yeah.
to 384 by 384.
Wow, that's a huge jump.
Right.
Yeah, like
So you can imagine how much more detailed and
Yeah.
accurate the models are.
that makes sense.
And they didn't stop there. They also have this material estimation network that goes beyond just the shape.
Oh, wow.
SF3D can actually predict material properties,
So-
like whether something is metallic or rough.
Oh, that's so interesting.
Yeah, so the lighting and the shading looks way more realistic.
Wow. So it's not just capturing like what the object looks like.
Right.
It's actually understanding what it's made of.
Exactly.
I'm imagining like game developers using this to scan real world objects.
Yeah.
Like for their games, and then
Totally.
because the materials are rendered so well,
Right.
it just looks
Super realistic.
yeah, like incredibly realistic.
That's a great example. And it really shows one of the best things about SF3D.
What's that?
You can create these super realistic 3D assets
Yeah.
really quickly and easily.
Okay, so this could like revolutionize game development then.
Oh, absolutely. It could make prototyping way faster.
Yeah.
And create way more immersive game worlds.
That is so exciting.
Right?
Okay, there's all this amazing stuff. And then the paper also talks about illumination modeling.
Yeah.
What is that? And like, what's its role in SF3D?
So illumination modeling is super important because it solves a really common problem in 3D modeling.
What's that?
It's called light bacon. Light bacon, okay.
Yeah,
Yeah.
it's where the shadows from the original image
Yeah.
get baked into the texture of the model.
Right.
And SF3D actually fixes that.
So instead of the model like being stuck
Yeah,
in the lighting of the original picture,
exactly.
you can adapt to different environments.
That's right. It's like you take a picture of a toy in your living room
Yeah.
with all the lights on.
Right.
And then you can drop that 3D model into like a dark dungeon in a video game.
Okay.
And it'll still look totally natural.
That's wild.
SF3D figures out the lighting in the input image.
Okay.
And then there's this delighting step that basically removes those baked-in shadows.
Wow. That is a game changer.
Literally.
Yeah. Literally and figuratively.
Yeah,
Oh my gosh. This just opens up so many possibilities.
for sure.
For 3D modeling, I'm thinking like e-commerce.
Yeah.
Like customers could view products
Right. In 3D.
in 3D and see how they look in different lighting.
Exactly.
That's incredible. Okay, so we've talked about all this amazing stuff.
But I'm curious, how does SF3D actually build the 3D mesh itself?
So they use this technique called marching tetrahedron.
Arching tetrahedron.
Yeah, basically converts that triplane representation
Yeah.
into an actual mesh.
Okay.
And then they refine it even more
Really?
by predicting things like vertex offsets and surface normals.
Wow. They really pay attention to detail.
They do. It's amazing.
Every step of the process.
Yeah.
It's incredible. Okay, I have to ask though, how does it compare to what's already out there?
That's a great question.
Does the paper show any like comparisons?
Yes, they do.
Okay.
They show how SF3D handles things like light bacon
Right.
and those jagged edges you sometimes see in 3D models.
Oh, yeah?
They're called marching cubes artifacts.
Okay.
And they actually have visual comparisons
Oh,
to show how much better it is than older methods like TripoSR.
TripoSR.
And the difference is huge.
I'd love to see those visuals.
Yeah.
But before we do, can you tell me more about the speed? The paper says that SF3D can generate 3D models in under a second.
I know, it's crazy, right?
How's that even possible?
So they do a bunch of clever optimizations.
Okay.
But one of the biggest things is how they approach UV unwrapping.
Okay, UV unwrapping. What is that?
So it's basically like taking the surface of a 3D model and laying it out flat onto a 2D plane.
Okay.
So you can add textures and colors.
Gotcha.
And they've come up with this really efficient way to do it.
Wow. So it's like they've streamlined the entire 3D modeling pipeline.
Exactly.
From analyzing the picture to creating the final mesh.
That's right.
Okay, let's take a look at those visual comparisons.
Let's do it.
And see the results for ourselves.
I'm excited.
Me too. This is amazing.
It is. So these visuals are really impressive. You can totally see how much better SF3D is than the other methods, especially when it comes to like complex lighting and surface details.
Sure.
There's one comparison with a 3D model of a motorcycle rendered with TripoSR.
Okay.
And it looks like it has this weird shadow baked into it.
Yeah.
But with SF3D, the lighting looks totally natural. Like the motorcycle is actually there.
Wow, that's amazing. Okay, so the paper mentions that SF3D was trained on synthetic data sets.
Yeah.
Can you explain what that means?
Sure. So synthetic data sets are basically like collections of 3D models that are made specifically to train these machine learning algorithms. It's like creating a virtual world where the AI can learn in a controlled environment.
So instead of using real-world pictures, which can be messy,
exactly,
they're using these like perfect 3D models.
Yeah, it's like a perfect world for the AI to learn in.
Gotcha. And that has some advantages, I'm assuming.
Oh, yeah, for sure.
Like what?
Well, with synthetic data sets, researchers can create a ton of training data.
Okay.
And they have complete control over everything.
Like what kind of things?
Like the lighting, the position of the objects, the materials, all that stuff.
So the AI can learn more effectively.
Right.
Without all the noise and clutter of real-world data.
Exactly. It helps them avoid a lot of the pitfalls of real-world data.
That makes sense. But it also makes me wonder, like, if SF3D was only trained on synthetic data, how well is it going to do with real pictures?
Right.
You know, real-world pictures are unpredictable.
That's a great question, and it's something the researchers actually talk about in the paper.
Oh, really?
Yeah, they know that real-world images are way more complex.
Yeah.
Like, you might have objects blocking each other or weird lighting or just the general messiness of the real world.
I'm picturing, like, trying to scan a messy desk.
Yeah.
With all sorts of stuff on it.
Exactly. That would be tough.
For any 3D reconstruction algorithm.
Yeah, it shows the limits of just using synthetic data. It's a great starting point.
Yeah.
But it doesn't totally prepare the AI for the real world.
It's like it aced all the tests in school.
Yeah.
But now it has to face the real world.
Totally. And the real world is a much harder test.
For sure. Okay, so the researchers are aware of this.
Yeah.
And they're trying to figure out how to make SF3D better at handling real-world challenges.
Right. It's definitely something they're working on.
Okay, this is all super interesting. But let's get back to the material estimation network for a second.
Sure.
I'm really intrigued by that.
Yeah?
Can you tell me a bit more about how it works?
So they actually have a separate neural network just for that.
Oh, wow.
It's called MaterialNet.
MaterialNet. That's cute.
I know, right?
Okay, so MaterialNet takes the input image and predicts what the object is made of.
Exactly. It's like it's studied this massive library of materials.
Okay.
And can now recognize them just by looking at a picture.
That's incredible. It's not just looking at the color, is it?
No, it's looking at the whole object and using its knowledge of different 3D objects in their materials.
And is it analyzing like every single point on the model?
No, that would be way too computationally expensive.
Right.
So it estimates a single metallic and roughness value.
For the whole object?
Yeah, for the whole thing.
Wow, that's so efficient.
It is.
But what if the object is made of like multiple materials?
That's a great question. And honestly, that's one of the things SF3D still struggles with.
Oh, okay.
Right now, it can only predict one material for the whole object.
So like a chair made of wood and metal?
Yeah, exactly.
Would be a problem.
Right, they'd need a more complex approach
to handle that.
Yeah, like maybe predicting different materials for different parts of the model.
Okay, so that's something they're still working on.
Yeah, definitely an area for future research.
So we've got material net, figuring out what the object is made of.
Right.
But how does SF3D actually get rid of those baked-in shadows?
So they have another separate network for that too?
Oh, wow. Another one.
Yeah, it's called LightNet.
LightNet. Okay.
And it analyzes the input image.
Yeah.
And figures out the lighting conditions.
So it's like LightNet is saying, okay, the light's coming from over here.
Exactly.
And it's creating shadows like this.
Yep. It's understanding the whole lighting environment.
So it's not just identifying the objects, it's understanding the whole scene.
Yeah. And once it gets the lighting,
it
can use that to delight the model.
Hey, light.
Yeah. Basically reverse the effects of the original lighting.
That's so cool.
I know, right? It's like taking a picture of a sculpture in a museum with all those spotlights and then being able to see that 3D model in your living room with natural light.
And it still looks perfect.
Exactly. Yeah. And that's really important for a lot of applications.
For sure. Okay, so material net figures out, the material light net figures out the lighting. Right. But how does all that come together to actually make the 3D geometry?
So that's where marching tetrahedra comes in.
Right.
It's a technique that's used a lot in computer graphics to make a mesh from a 3D representation.
Gotcha.
So in SF3D, it takes that triplane representation, which is basically like a 3D volume of data, and turns it into a mesh, which is like a bunch of connected triangles make up the surface of the 3D model.
So the triplane is like the blueprint.
Yeah.
And marching tetrahedra is the construction crew.
I like that analogy.
Building the actual 3D structure.
Perfect.
And SF3D doesn't stop there.
Nope.
It also predicts things like vertex offsets and surface normals.
Right.
To make the mesh even better.
Exactly.
Okay.
They're all about the details.
So can you break those down for me?
Sure. So imagine you're building something with Legos.
Okay.
Vertex offsets would be like moving each Lego brick just a little bit to make a smoother curve instead of a jagged edge.
Oh, okay. So it's like fine-tuning the shape.
Exactly.
To make it more realistic.
Yep. And surface normals are basically like arrows.
Arrows?
Yeah, that point out from the surface of the model.
Okay.
And they show which way the surface is facing.
Okay.
And that's really important for the lighting.
How so?
Because it tells the computer how the light should bounce off the object. Oh, that makes sense. So if the surface normal is pointing at a light, that part will be bright.
Right.
And if it's pointing away, it'll be in shadow.
You got it.
Wow. This is all making so much more sense now.
Good.
So we've got the triplane as the blueprint, marching tetrahedra as the construction crew vertex offsets for fine-tuning and surface normals for realistic lighting.
That's it.
And it all happens in under a second.
I know, it's crazy.
Yeah, that's mind-blowing. Okay, so let's talk more about that speed.
Okay.
You mentioned that SF3D uses a super efficient technique for UV unwrapping.
Yeah.
Can you explain that a little more?
Sure. So UV unwrapping is basically taking a 3D model and figuring out how to flatten it out onto a 2D surface.
Like a map.
Exactly like a map. So you can add textures and colors.
Okay, I'm picturing like peeling the Earth's surface off and laying it flat so you can paint all the different countries.
Perfect analogy.
Okay, so how does SF3D make that process so fast?
Well, the old ways of doing it are pretty slow and complicated.
Yeah. But SF3D uses a technique called cube projection.
Cube projection.
Yeah, and it's designed for speed.
Okay.
Basically, it projects each face of the model onto a cube, which you can then unfold really quickly.
So it's breaking the model down into smaller chunks.
Exactly.
That can be processed at the same time.
Right, that's the key. It's called parallelization.
Parallelization.
And it lets them use all those cores in modern processors.
So you can do the UV unwrapping way faster.
Exactly.
Wow, they really thought everything.
It seems like it.
To make this process as fast and efficient as possible.
Yeah, they really optimized the whole pipeline.
That's impressive. But the paper also says that this cube projection thing can cause some problems.
It can.
Especially with real-world pictures.
Yeah.
Like what kind of problems?
So cube projection works great for a lot of objects.
Okay.
But when you have a bunch of objects overlapping, it can get tricky.
Like trying to unfold a pile of clothes.
Exactly. It's not as easy as unfolding a cube.
Right. Okay, so in those cases, the UV unwrapping might not be as accurate.
Yeah, it can be less accurate and less efficient.
So that's something they're still working on.
Yeah, for sure. They're trying to find ways to make UV unwrapping even better.
to handle those tricky real-world situations.
Exactly, where cube projection might not be the best option.
Okay, let's go back to those limitations of using synthetic data for a minute.
Okay.
The paper specifically says that SF3D might not always work well with real-world images because it was trained on those idealized synthetic data sets.
Yeah.
Can you talk more about the specific challenges they mentioned?
Sure. So one of the biggest ones is occlusion.
Occlusion.
Yeah, which is basically when one object is blocking another. In synthetic data sets, you can make sure that never happens.
Right.
But in the real world, it's everywhere.
Yeah, things are always in each other's way.
Exactly, and that can really mess up the 3D reconstruction.
Especially if important parts of the object are hidden.
Right.
Okay, what else?
Another big one is lighting variations.
Okay.
Synthetic data sets usually have like perfect lighting.
Yeah.
But real-world lighting is way more complex.
Right, with multiple light sources and shadows and reflections.
Exactly. So even though SF3D is really good at removing baked-in shadows, it might still struggle with the more subtle lighting in the real world.
That makes sense. Okay, anything else?
Yeah, they also talk about just the huge variety of objects in the real world.
Right.
Synthetic data sets usually focus on a pretty limited set of objects, but the real world has all kinds of crazy shapes and textures and materials.
So it's like SF3D has learned a certain vocabulary, but it might not know what to do with a completely new language.
That's a great way to put it.
Okay, so what are they doing to address these limitations?
Well, they're exploring a few different things.
Like what?
One idea is to use more real-world data in the training process.
So basically give SF3D more experience with the real world.
Exactly. Expose it to all the different objects and lighting conditions and occlusions.
Okay, that makes sense, but wouldn't that be really hard to do?
It would be a lot of work for sure.
Like, how would they even collect all that data?
Well, there are a few options.
Okay.
One is to use existing 3D model libraries.
Oh, right, like online platforms where people share 3D models?
Exactly. There's tons of data already out there
that they could use.
Yeah, they could just curate it and use it for training.
That's a good idea. What else?
Another idea is crowdsourcing.
Crowdsourcing?
Yeah, like imagine an app that lets people scan objects with their phones.
Cool.
And then they contribute those scans to a global 3D model data set.
It's like a citizen science project for 3D modeling.
I love that.
Okay, so the more people contribute, the better the data set becomes.
Exactly, and the more robust and generalizable the AI models will be.
That's a future I'm excited about.
Oh, me too. It's really cool to think about.
Okay, so it's not just about collecting data.
Right.
They're also working on new algorithms.
Yeah.
That can handle the challenges of real-world data.
Exactly. There's a lot of active research in that area.
Can you give me an example?
Sure. One area they're focusing on is occlusion.
Right.
They're trying to find ways to figure out the hidden parts of objects.
Even though they can't see them.
Right. It's like teaching the AI to fill in the blanks.
That's wild.
Based on its knowledge of how objects usually look.
Okay, so it's using context clues.
Exactly.
To complete the 3D model.
Yep. Pretty cool, right?
That's amazing.
Okay, what else? They're also working on better lighting estimation and delighting techniques.
Okay.
Some researchers are using neural networks that can figure out not just the direction and brightness of the light, but also the materials and reflections of the objects.
Wow, so the AI is basically learning to see like an artist.
Yeah.
Considering all those subtle details of light and shadow.
Exactly. It's pretty amazing how far this technology has come.
I know, it's mind-blowing to think that what used to require special software and expensive equipment is now something you can do with your phone.
It really is a democratization of 3D modeling.
Totally. Okay, so we've talked about all this exciting stuff.
Yeah.
But it's important to remember that SF3D is still a research project.
It is.
It's not perfect.
Right.
And it has its limitations.
Absolutely.
So we can't get too carried away with the hype.
Yeah.
We need to be realistic about what it can and can't do.
Exactly. And we need to keep researching and evaluating these technologies.
That makes sure they're used responsibly.
That's right. We need to be mindful of the potential impact they could have.
On society as a whole.
For sure.
Well, this has been an incredible deep dive into SF3D.
It has.
Thank you so much for sharing your expertise with us.
It's been my pleasure.
And to our listeners.
Yeah.
We encourage you to check out the project page mentioned in the paper.
Yeah, it's really cool.
We'll put a link in the show notes.
Great.
And as always.
Yeah.
Thanks for joining us on the deep dive.
See you next time.
Yeah, it is a really fascinating challenge, isn't it? Like, how do you bridge that gap between the synthetic world and the real world?
It is, and it really highlights just how much we still have to learn about training AI to truly understand the real world.
Yeah, the paper talks about incorporating real-world data into the training process.
Yeah.
But wouldn't that be super time-consuming and expensive?
It would definitely be a big project.
Like, how do you even start collecting enough data to cover all the different objects and environments out there?
Well, there are some interesting approaches out there.
Okay, like what?
One idea is to use 3D model repositories that already exist.
Oh, okay.
Like online platforms where people share 3D models.
Right.
There's actually a ton of data already available online.
So they could just use that.
Yeah, they could curate it and use it for training.
That makes sense. What other options are there?
Another cool idea is crowdsourcing.
Crowdsourcing.
Yeah, imagine an app that lets people scan objects with their phones. And then they upload those scans to a giant 3D model data set.
That's such a cool idea.
Right.
It's like a citizen science project for 3D modeling.
Exactly. And the more people participate, the better the data set gets.
Right. And the more the AI can learn.
Exactly. The models will become more robust and they'll be able to handle more real-world situations.
I love that idea. Okay, so it's not just about collecting data, though, right? They're also developing new algorithms.
Yes.
To deal with the messiness of real-world data.
Absolutely. There's a ton of research happening in that area.
Like what kind of things?
Well, one example is occlusion.
Right.
Remember when objects are blocking each other?
Yeah.
They're working on algorithms that can actually figure out what the hidden parts of an object look like.
Wow, even though they can't see them.
Yeah, it's like the AI is learning to fill in the gaps.
Based on what it knows about other objects.
Exactly. It's using its knowledge to make educated guesses.
That's incredible. What else are they working on?
Another area is lighting. They're developing new techniques for estimating the lighting in a scene.
Okay.
And for removing those baked-in shadows.
So the AI is basically becoming a lighting expert.
Pretty much. Some researchers are even using neural networks that can figure out the materials and reflections in a scene.
Wow. So the AI is not just seeing the shapes of objects.
Right.
It's understanding how light interacts with them.
Exactly. It's learning to see the world more like a human artist.
This is all so mind-blowing. It's amazing how far this technology has come.
I know, right?
Like what used to require all this expensive equipment, you can basically do on your phone now.
It's crazy.
It really is making 3D modeling accessible to everyone.
It is. It's a really exciting time to be in this field.
It is. But it's also important to remember that SF3D is still in its early stages.
It is.
It's not perfect.
Definitely not.
There are still limitations.
For sure.
So we need to be careful about getting too carried away with the hype.
Yeah. I agree.
We need to keep researching and testing and make sure we're using this technology responsibly.
Absolutely.
Well, this has been an incredible deep dive into the world of SF3D.
It has been fascinating.
Thank you so much for sharing your expertise with us.
It was my pleasure.
And to our listeners, be sure to check out the project page that's mentioned in the paper.
Yes, definitely.
You can find a link in the show notes.
Great.
And as always, thanks for joining us on the deep dive.
Until next time. Oh.
All right, picture this. You're working on a project, and you need to create a 3D model.
Yeah.
Maybe it's for a game. Maybe it's for like a presentation or even, just for fun. In the past, that was a pretty daunting task.
Yeah.
I mean, it was like climbing Mount Everest, but in flip-flops.
Yeah, really. It was quite the process. You needed specialized software hours of work.
Exactly. And even then, you weren't guaranteed amazing results, right? A lot of times you'd end up with like weird shadows baked right into the model.
Yeah, you'd get like a dog and the sunlight would be like part of its fur permanently.
Yeah, or like clunky textures, jagged edges. It was a whole thing.
Yeah, those were definitely some of the downsides of older methods. Like you mentioned that light bacon issue. It made objects look totally unnatural under different lighting.
Right.
And then you had things like vertex coloring that would limit the texture detail, and the mesh extraction would often leave these rough edges.
Ugh. Yeah, I remember those days. But get this. Today we're diving into something that changes the game completely. SF3D. This new method can create a detailed 3D model from just one image. And get this in half a second.
Yeah, it's super impressive. It's a huge leap forward. It actually builds upon this previous method called TrypoSR, but it brings in some really innovative upgrades.
So, okay, let's unpack this SF3D magic a bit. It all starts as something called an enhanced transformer.
Right.
So what exactly is that?
So think of a transformer as like the brain behind the operation.
Okay.
Older methods used transformers too, but they were kind of limited in the level of detail they could produce.
Right.
So you ended up with those blocky, low-resolution models. SF3D uses a much more powerful transformer, and it creates what we call these super detailed triplanes.
Triplanes. Okay, now we're getting into the weeds a little bit. What are those?
So imagine them as like 3D blueprints for the object. They're like 3 intersecting planes, and they capture the object's shape from different angles.
Oh, okay.
And SF3D's enhanced transformer generates these triplanes with incredible detail, and that really lays the groundwork for a high-quality 3D model.
Okay, I'm with you. It's like starting with a really, really precise blueprint.
Yeah.
But how does SF3D then go from that blueprint to figuring out what the object is actually made of? Like, how do we go from blueprint to, say, like a shiny metal surface or a rough wooden texture?
Right. Well, that's where material estimation comes in.
Okay.
Most methods just focus on capturing the object's color, but SF3D takes it a step further. It actually predicts the material properties of the object.
Wow.
Like things like how metallic the surface is or how rough it is.
But it's not just capturing the look of it, it's actually understanding what it's made of.
Yeah, exactly.
That's wild.
And the really cool thing about that is that you can then relight the 3D model realistically, just like you would in like professional rendering software.
Oh, wow.
You don't have to worry about those baked-in shadows anymore or any weird lighting artifacts.
I'm already seeing how this is such a huge leap forward.
Yeah.
So, okay, we've got the shape, we've got the materials figured out, what's next in this process.
All right, so after generating the triplanes, SF3D moves on to mesh extraction and refinement.
Okay.
So basically, those triplanes are converted into a 3D mesh, which is like a digital wireframe of the object.
Right.
And then SF3D refines that mesh, it smooths out surfaces, and enhances fine details. So you end up with a much more realistic and polished-looking 3D model.
And no more jagged edges.
Exactly.
One of my pet peeves with those old models.
Yeah. SF3D really takes care of that. And then finally, there's this process called fast UV unwrapping.
Right.
Think of this as like taking a 2D texture, like a photo of a brick wall, and wrapping it seamlessly onto that 3D object. SF3D has a super fast way of doing this, which again adds to its really impressive speed.
Okay, so before we go too far down this road, let's pause for a sec and bring this back to our listeners.
Yeah.
Why should all this technical stuff even matter to them?
Well, the applications are huge. I mean, imagine creating 3D models on the fly.
Right.
For video games, for product prototypes, for data visualization, the list goes on. SF3D really lowers the bar for 3D content creation.
It's like putting this super powerful 3D modeling tool in everyone's hands.
Yeah, exactly.
And a total game changer for industries like AR, VR, e-commerce and beyond.
Yeah, definitely.
But there's something I find particularly fascinating about SF3D's training process.
Oh, yeah. What's that?
So to teach the material prediction part, the researchers used a set of objects that already had realistic, physically based rendering materials. It's like giving the AI a crash course in what real materials actually look like.
That's a good way to put it.
Right.
Yeah, and what's interesting is that this technique could be used to train on real-world images in the future.
Oh, wow.
Instead of relying on synthetic data sets, you can imagine SF3D learning directly from photos and videos of our world.
That would be incredible.
Yeah, it would be a whole new level.
Okay, so we've talked about the enhanced transformer and how it creates those super detailed triplanes. What about this material net we touched on earlier? How does that actually work?
Yeah, so the material net is a critical part of what makes SF3D so innovative.
Okay.
It's all about analyzing the image and predicting the properties of the materials that make up the object. Things like how metallic it is, how much light scatters beneath the surface, it's all considered.
Is it like looking at the colors and then making an educated guess?
Well, it's a bit more sophisticated than that.
Oh.
The material net actually uses a pre-trained network called CLIP.
Okay.
And CLIP is amazing because it's been trained on this massive data set of images and text. So it understands how we describe objects and materials using language.
So it's like the material net has read a whole library on materials.
You could say that, yeah.
That's really cool.
And by tapping into CLIP's knowledge, the material net can then extract meaningful information from the image and use that to predict the material properties.
Wow.
But what's really interesting is that instead of just giving single values for things like roughness, it gets even smarter.
Smarter. How is that even possible?
Well, the material net predicts the parameters of a beta distribution.
Okay.
Which is basically a way of expressing uncertainty, like saying, I'm pretty sure this object is mostly metallic, but there's a chance it could be less so.
So it's not just making a random guess, it's giving a range of possibilities.
Exactly.
Gotcha.
And this approach prevents the network from getting stuck in a rut. always predicting the same values. It keeps things flexible and allows for more accurate predictions.
Pretty cool.
Yeah.
Okay, so we've got the shape nailed down with the enhanced transformer.
Right.
We've got the materials figured out with the material net. What else is there to consider when creating a realistic 3D model?
Well, we can't forget about lighting.
Right, of course.
SF3D has a dedicated component for illumination modeling because the lighting in the original image can dramatically affect how the object appears.
Yeah, like that car we talked about with the permanent sunshine, right?
Exactly. We don't want that.
No.
So SF3D's illumination modeling component uses a technique called spherical Gaussian lighting. Or think of it as representing the light in the scene as a set of virtual light sources, each with its own position, intensity, and color.
So it's like digitally removing the original lighting and replacing it with a custom setup.
Precisely.
That's pretty easy.
And that way, the 3D model can look realistic under any lighting you throw at it.
Oh, wow.
You can even change the lighting in real time and see how the object responds.
That's awesome. It's like having a virtual photography studio.
Exactly.
Okay, so we've covered the enhanced transformer, the material net illumination modeling. Before we move on to the final stage of actually creating the 3D model, let's pause for a second, bring our listener back into the conversation. What's standing out to you so far? What part of SF3D has surprised you the most? Take a moment to ponder that, and we'll be right back to dive into those final steps.
All right, welcome back. I hope you had some time to think about everything we've talked about so far with SF3D. Now let's take a look at how those super detailed triplanes we discussed actually get turned into a usable 3D mesh. The kind you could actually use in a project.
Yeah, it's like the grand finale where everything comes together.
Exactly.
So walk us through what happens after SF3D creates those triplanes.
So the first step is something called mesh extraction.
Okay.
And remember, those triplanes are like those detailed blueprints we talked about?
Yeah.
Mesh extraction takes those blueprints and builds the actual structure.
Oh.
A 3D mesh, which is basically a digital wireframe of the object.
Right.
SF3D uses something called differentiable marching tetrahedra to do this, or DMTET for short.
DMTET, okay, that sounds a little intimidating.
Yeah, it's a mouthful.
Can you break that down for us non-technical folks?
Sure. So it might sound complex, but the idea is pretty simple.
Yeah.
Imagine dividing 3D space into a bunch of tiny tetrahedra.
Like those pyramid shapes.
Yeah, exactly.
Okay.
And DMTET basically analyzes the triplanes and figures out which tetrahedra need to be filled in to create that object's shape.
So it's like taking those blueprints and then building a structure block by block.
That's a really good analogy.
Okay.
But SF3D doesn't stop there. It also uses a technique called mesh refinement to smooth out any rough edges and enhance the finer details.
Gotcha. So that's why the models look so smooth.
Yeah, exactly. Older methods would often result in models with those jagged, blocky surfaces. SF3D avoids that with this extra refinement step.
I'm with you. Okay, so the mesh is created and refined, but I'm still a little fuzzy on this whole UV unwrapping thing.
Right. Yeah.
How does SF3D actually take a 2D texture, like that brick wall we talked about, and wrap it onto a 3D object?
Yeah, so UV unwrapping is kind of like if you took a piece of wrapping paper and laid it out flat so you could see the whole design. In the 3D world, this means creating a 2D map.
Right.
That shows exactly how a 2D texture should be applied to the 3D object's surface.
So it's like a set of instructions for painting the 3D object.
Exactly. And SF3D has a really fast way of doing this, which is one of the reasons it's so much faster than those older methods. It uses something called cube projection.
Cube projection?
Yeah, so basically each face of the 3D mesh is projected onto a virtual cube.
Oh, okay. So each face gets its own little section of the wrapping paper, so to speak.
Precisely.
Okay.
And then SF3D uses some algorithms to make sure that there are no gaps or overlaps in the final texture.
Wow, so there's a lot of detail that goes into making a realistic 3D model.
There really is. It's quite a process.
It's amazing that SF3D can do all this in half a second. Those triplanes, the mesh, the smoothing the textures, it's mind-blowing.
Yeah, it really is a testament to how far this technology has come.
And the applications are endless, right? I mean, think about video games, virtual reality, e-commerce.
Oh, yeah. The possibilities are huge. I mean, imagine creating 3D models on the fly for all those things and more.
Exactly.
It really opens up a whole new world of possibilities.
What always blows my mind is how SF3D can actually learn those material properties just from a single image. It's like magic.
It's pretty amazing, right? And remember how the researchers used objects with those physically based rendering materials to train the material net?
Yeah.
Well, that opens up some really exciting possibilities for the future.
Like what?
Well, imagine training SF3D directly on real-world images instead of using those synthetic data sets.
Yeah.
It could learn directly from photos and videos of our world.
Wow, that would be incredible.
Yeah, it would be a whole other level.
Okay, so we've talked about the enhanced transformer, the triplanes, the material net, how it analyzes the image to figure out what the object is made of.
Right.
Is there anything else going on here? Like, how does SF3D deal with lighting, for example?
Yes, lighting. That's crucial. SF3D actually has a dedicated component for illumination modeling because the lighting in the original image can really impact how the object looks. Remember we talked about that car with the permanent sunshine?
Yeah, we definitely want to avoid that.
Exactly. So SF3D's illumination modeling component uses a technique called spherical Gaussian lighting.
Spherical Gaussian lighting, okay.
Yeah, basically it represents the light in the scene as a set of virtual light sources, each with their own position, intensity, and color.
So it's like digitally removing the original lighting and replacing it with a custom setup.
Precisely.
That's very cool.
Yeah, and that way the 3D model will look realistic under any lighting conditions.
Wow.
You can even change the lighting in real time and see how the object responds.
It's like having a virtual photography studio.
Exactly.
Okay, so we've got the enhanced transformer handling the shape, the material net, figuring out the materials, and illumination modeling, taking care of the lighting. That covers the major components of SF3D, right?
Yeah, that's pretty much it.
So what happens next?
Well, now that we've got all the pieces in place, it's time to assemble them. We need to take those detailed triplanes and convert them into an actual 3D mesh that can be used in real-world applications.
Okay.
This involves a process called mesh extraction and refinement, along with a super fast technique for UV unwrapping.
So it's like putting those finishing touches on the masterpiece.
Exactly. But before we jump into the nitty-gritty of those final steps, I think it's a good time to bring our listeners back into the conversation. What has been the most surprising or intriguing thing you've learned about SF3D so far? Think about it for a minute, and we'll be right back to explore those final steps in the 3D model creation process.
All right, welcome back. I hope you've had a chance to think about what we've discussed so far with SF3D.
Yeah, it's pretty amazing technology.
It really is. So now it's time for the grand finale, right?
Yeah.
We get to see how those intricate triplanes are transformed into an actual 3D mesh that we can use.
That's right. It's like the culmination of all those incredible processes we've been talking about.
Exactly. So let's dive into those final steps. What happens first?
So the first step is what we call mesh extraction. And if you remember, those triplanes are like those really detailed 3D blueprints we talked about.
Right.
Mesh extraction takes those blueprints and builds the actual structure, the 3D mesh, which is essentially a digital wireframe of the object.
So it's kind of like using those blueprints to actually construct the building. But in this case, the building is a 3D model.
Exactly, a great analogy.
Okay, so how does it actually work?
Well, SF3D uses a technique called differentiable marching tetrahedra, or DMTET for short.
DMTET.
Yeah, I know it's a mouthful.
It sounds pretty complex.
It might sound complex, but the idea is actually pretty simple. Imagine dividing 3D space into a bunch of tiny tetrahedra.
Okay, those pyramid shapes.
Yep, exactly. DMTET analyzes the triplanes and figures out which of these tetrahedra need to be filled in to create the object's shape.
So it's like a super precise connect the dots puzzle, but in 3D?
That's a perfect way to put it. The triplanes tell you where to connect the dots, and the result is the object's shape.
That's so cool.
But SF3D doesn't stop there. It goes a step further with mesh refinement.
Okay.
This process smooths out any rough edges and enhances those finer details. Remember how those older methods often resulted in models that had those jagged, blocky surfaces?
Yeah.
Well, SF3D bypasses that with this refinement step.
That makes sense. So that's how SF3D models end up looking so smooth and polished.
Exactly.
Okay, so now we have the mesh all created and refined, but what about the textures? How does SF3D take a 2D texture like that brick wall photo we talked about and actually wrap it onto the 3D object?
Right, that's the UV unwrapping part.
Yeah.
Think of UV unwrapping like taking a piece of wrapping paper and laying it out flat so you can see the whole design. In the 3D world, this means creating a 2D map that shows exactly how a 2D texture should be applied to the 3D object's surface.
It's like a set of instructions for painting the 3D object with the texture.
Exactly. And SF3D has a really fast way of doing this, which is another reason why it's so much faster than those older methods. It uses something called cube projection.
Cube projection.
Yeah, so each face of the 3D mesh is projected onto a virtual cube.
Ah, okay. So each side of the cube gets a little section of the wrapping paper, so to speak.
Precisely.
Yeah.
And then SF3D uses some clever algorithms to make sure that there are no gaps or overlaps in the final texture. It even adds margins to the UV map to avoid any visible seams between different parts of the texture.
It's amazing how much detail goes into creating a truly realistic 3D model.
It really is. It's a pretty remarkable process.
S3D takes those triplanes, converts them to a mesh, smooths everything out, wraps the texture on all in half a second.
It's mind-blowing how fast it is.
It really is, and the applications are endless, right?
Mm-hmm.
I mean, video games, virtual reality, e-commerce, you name it.
Absolutely. The possibilities are truly endless. Imagine creating 3D models on the fly for all of those things and more.
It's exciting just thinking about it. What always gets me is how SF3D can learn those material properties just from that single image. It's almost like magic.
It is pretty magical. And remember how the researchers use those objects with those physically based rendering materials to train material net?
Right.
Well, that opens up even more exciting possibilities for the future.
Like what?
Well, imagine training SF3D on real-world images directly instead of using those synthetic data sets.
Okay.
It could learn directly from photos and videos of our world.
That would be incredible.
It would be a whole new level. We've only scratched the surface of what this technology can do. Imagine combining SF3D with other AI tools like those text-to-image generators we've been hearing so much about. Could we someday describe an object and have a perfect 3D model generated instantly?
Whoa.
Or even use SF3D to reconstruct entire 3D scenes from videos? The possibilities are mind-boggling.
It really feels like the future of 3D content creation is unfolding right before our eyes.
It absolutely is. And who knows, maybe someday we'll all be using SF3D to create our own virtual worlds and experiences.
I'm excited to be a part of it. It's a future full of possibilities.
Absolutely. So here's a final thought for you to ponder. If you could instantly create any 3D object, what would it be? Let your imagination run wild, because with the power of SF3D, that object might not just exist in your mind, but also in the digital world sooner than you think. Until next time, keep exploring, keep learning, and keep diving deep.